Every year for the last 8 years, we have embarked on a frantic 6-week design and build of our frisbee launching, basketball shooting, ramp balancing, exercise ball tossing, castle storming 120-pound robot. In our first year, the team consisted of 6 students and 4 teachers. In year 2, NEF was a partial sponsor of our almost $5,000 in entry fees and costs. As corporate sponsorship grew, NEF's 501c3 status became a vehicle for donor companies such as Navistar and Molex to gain maximum tax advantage for their substantial annual financial support of the team. NEF's seed money has resulted in a team now with anywhere between 60 and 100 members that routinely graduates 10 to 15 engineering or science majors per year. NEF also granted the purchase of over $5,000 in new tooling for our recently acquired milling machines and metalworking lathes. Now listen to what the students have to say.
In high school, I was kind of deciding what I wanted to do with the rest of my life, and science and engineering wasn't really up there. Not because I was bad at it, but because I didn't really have the confidence in what I was doing, and really just how fun robotics competitions were inspired me to go into engineering, because I saw that engineering was not really the stereotype that I thought it was, but rather it was incredibly social, because you were constantly working with other people to solve problems. Now I'm an electrical engineering major here at Caltech. I've never done anything like electrical engineering before, so it's a little difficult for me. But Husky Robotics has really given me the confidence, even without being a technical person on the team and without doing anything technical. Husky Robotics has given me the confidence to know that I can get through this major, because I've seen that engineering is really what I want to do with my life, and I can't really imagine doing anything else now.
Being a member of that team, that was the first time that I really felt that I was capable of being an engineer someday. That was the first time that I really felt like no matter how much I felt like I may have stood out or been different or maybe not have been necessarily as smart as the other kids, I felt like I was absolutely capable of being there and capable of learning and doing everything else that everyone else could do, and that's something that I had never really experienced before, so it really meant a lot to me. In my final job interview for my internship last summer, which was actually the summer after my freshman year of college, I talked about Husky Robotics, and I talked about the applications of a lot of the subsystems and how that helped me to understand my classes as well as apply the concepts I had learned in my classes to my real life. And then as a freshman in college, I actually got my first full-time internship, which is absolutely incredible, and I have so much experience going into my sophomore year from that. And that never ever would have been possible if it hadn't been for my experiences through Husky Robotics.
I often tell my students that physics is the fusion of art and math. I always want them to make a sketch of the situation to help make sense of it. It's also a well-known fact that involvement in the arts and music leads to greater scientific creativity. Of course, failure is definitely an option in artistic endeavors. Yet, many students never get to see the inside of an art classroom at North due to effects that some elective courses can have on student GPAs. By granting the art of physics, NEF gave over 120 students exposure to the process of raku firing of pottery pieces that they themselves threw on pottery wheels in the ceramics classroom. The grant was coordinated by art students not traditionally present in the AP Physics classroom and gave students the chance to see how difficult centering and throwing pottery pieces can actually be. It gave them an appreciation for rotational motion in action. It also introduced them to glaze chemistry and an understanding of the ancient Japanese style of pottery firing. Some students even enrolled in art classes the next semester.
I was also in Mr. Rousey's honors physics class junior year, and so I got the opportunity to create pottery, and I still have my pot right here. It actually ended up being a bottle. I decided to do bottles even though I was told that bottles were way harder to do. I had done plenty of artwork before, not too much pottery, not too much 3D stuff, but I thought, how hard could this be? and it ended up looking like this. This is definitely a memory that I will cherish for the rest of my life. Hopefully I can keep this bottle forever if it doesn't break first. But I'm also very glad that I got to have that enriching experience in physics, because I never thought that we would be doing pottery in physics.
Imagine the feeling of fear that two teachers must have experienced after 30 minutes of phone calls between FAA inspectors, field offices, and O'Hare Control Tower personnel immediately before the launch of an unguided 8-foot helium-filled balloon with science payloads into U.S. airspace. Or better yet, the 40-mile relocation of a launch based on weather predictions that your balloon would drift into the 30-mile no-fly zone surrounding Chicago during the G8 summit, all while transmitting a traceable, conspicuous ham radio call sign to ground base observers. What started with a GPS-enabled cell phone, a $300 balloon, and two unnamed teachers in the rainy, muddy forests of Covington, Indiana at midnight, arriving at school empty-handed the next morning at 5 a.m., became a student-parent cooperative to recover our first launch. Multiple NEF grants have purchased the specialized balloons and reusable ham radio tracking equipment that we use. For more sophisticated launches, we have used up to 5 cameras, and we've launched payload experiments from District 203 elementary and junior high classrooms that were mentored through the process by Naperville North Physics Club students. Over 150 students have learned the rigors of experiment payload design for high-altitude atmospheric conditions in excess of 105,000 feet. That's nearly 20 vertical miles. 5 launches later, we've only lost 1 payload in December of 2014. From failure resulted a student's beautiful project which made predictive tracks of the landing location of our lost payload based on actual weather data at 1,000-foot burst intervals, starting at 80,000 feet and rising up to 115,000 feet. As indicated, the NEF ballooning grants have inspired many students. Some launch participants have obtained summer internships at Adler Planetarium and NASA's Goddard Space Flight Research Center. Another formed a money-making ballooning venture called Space for All and produced a commercial involving the first bicycle jersey in space, as well as conducting environmental surveying of large land areas. Undersea exploration remains one of the greatest, most accessible research frontiers. The Science Under the Sea grant enabled almost 50 Jefferson Junior High students to design, build, and drive their first underwater remotely operated vehicles, or ROVs. Building the ROV frames to make them perform specialized tasks, wiring and waterproofing cameras and motors, troubleshooting, and coordinating complex underwater driving maneuvers were part of what participants learned while being mentored by Naperville North High School Physics Club participants on a weekly basis. During one build day, students got to watch live, real-time video feed of an ROV being used to service undersea equipment in the Gulf of Mexico. They were also able to Skype live with the ROV operator. Many of these materials will be reused for future builds. The Student-Inspired Science in the Sky grant, awarded by NEF, supported almost 50 junior high students from Jefferson and Washington during a semester-long weekly build of 9 quadcopter drones. These were not kit drones. With the help of NHS Physics Club, all components for the quadcopters were sourced online and painstakingly, and sometimes mistakenly, assembled during the weeks that ensued. By the end of the semester, the junior high participants understood what it took to integrate complex parts such as GPS units, gyros, electronics, video transmitters, propellers, brushless motors, and frames, while considering weight and balance restrictions. They also learned introductory quadcopter flying skills. NHS Physics Club student mentors learned what it takes to harness the energy of 5 to 7 junior high students per group. Enough said. Know that when you donate to NEF, you are supporting innovative initiatives that enrich students' lives and their futures.
So thank you. And yeah, Mr. Rousey, you can use that. Like, I'm thinking like some sort of montage at the ending. That'll be a whole bunch of like students saying like, so thank you, NEF, and I'll be one of them. So I can do a few for you if you want. So thank you, NEF.
So in closing, I want to thank everyone at the Naperville Education Foundation.
Thanks, NEF.
Thank you, NEF.
Thank you to the NEF.
So thank you so much.
Thank you, NEF. Okay, that's all I got. If you need more, hit me up. I'll get you some more. Thanks.